Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about parallel processing. So what is parallel processing? The term parallel processing or pipelining refers to a technique of decomposing a sequential process into sub-operations, with each sub-operation being executed in a dedicated segment that operates concurrently with all other segments. The most important characteristics of a pipeline technique is that several computations can be progressed in distinct segments at the same time. So in the previous session we discussed pipelining. So today we are discussing parallel pipelining. So actually what is a pipelining? It is a technique for decomposing a sequential process into sub-operations. Suppose I have to add AX, BX, CX. Otherwise, if I am going for A plus B into C plus D. So A plus B is one operation and one sub operation. Totally it is one operation. But here A plus B is one sub operation and C plus D is another sub operation. So multiplication is the one sub operation. But here A plus B and C plus D parallelly we have to do. Okay, there is no depend on one to another. So A plus B, C plus D we will do parallelly the operation. So two sub operations can be performed parallelly. And what is the result of A plus B? Suppose A plus B result is X and C plus D result is Y. So we have to go for X into Y. Okay, it is a one sub operation. So there is a three sub operations is going as a one operation. So that is the pipelining. So pipelining is a process. It is a technique how we are doing in a one operation. So one operation we are dividing as a sub operations to perform this one. And here A plus B one sub operation, C plus D another one, and A plus B into C plus D multiplication. So here A plus B one and here A plus B is a OR, C plus D is a OR, and it is a multiplication is I am going for the AND. So here we are performing three logic gates. So how we are planning? Is it parallel is a possibility or serially possibility? How it is possibility? So it is a technique to process, that is a pipelining. So the most important characteristics of a pipeline technique that several computations can be progressed in distinct segments at the same time. So if I am going for the parallel processing at a time, okay, at a time the two sub operations are performed. So it is a progress to distinct segments at the same time. Two operations are performing like this. So it is the OR gate we required. It is also OR gate we required. So it is one sub operation. It is also one sub operation. And it is a sub operation. So two OR gates, one AND gate. So totally three gates we required. So two OR gates, this we are going for the parallel operation. And after the result, parallelly means A plus B and C plus D we are performed parallelly. And what is the result of A plus B? Suppose I am taking X, C plus D equal to Y. So X into Y. So this operation is parallelly performed. Okay. So parallelly performed. So A plus B and C plus D are performed parallelly. And what is the result of A plus B and C plus D? We are doing multiplication is parallelly. So it is a parallel processing of the sub operations. The following block diagram represents the combined as well as the sub operations performed in each segment of the pipeline. Suppose I am taking A storing belongs to R1 and B belongs to R2. Okay. So here I am going for the multiplier. Multiplier means A into B or R1 into R2. So this multiplication is going as a parallelly. Parallelly I am taking the values here. Okay. So parallelly the R1 value and R2 values are storing in multiplier. So here R1 into R2 or A into BA. So parallelly the multiply is performed. Here R3. So what is the result? R3 equal to R1 into R2. So the resultant value of R1 into R2, the multiplication value is stored in R3. So here R3 is equal to R1 into R2 value. So what is the value of R1 and R2? The R3 value is stored in R3 register and it is going to the adder. So externally I am adding another register, that is a R4. So here R3 is there. What is the value of R3? I am taking some 0, 1, 1, 0 like this. Suppose I am taking R4 equal to 1, 0, 0, 1. Example I am taking. So here adder means R3 value of 0, 1, 1, 0 plus R4 value 1, 0, 0, 1. We have to add in the adder. So shall we add parallelly? Yes, it is possible to add parallelly. Why? Because R3 value is already there. It is ready to accept 0, 1, 1, 0 and R4 value also ready to accept. So R3 plus R4. So what is the result value? Result value is storing in R5. So R5 equal to R3 plus R4. So these operations are performed parallelly. So first one R1 and R2 equal to R3. Shall be parallelly performed? Yes, it is a parallelly performed. Next R3 result is a parallel performance of R1 and R2. Next R3 and R4 are performed parallelly. Yes, it is parallelly performed. So R3 and R4 also parallelly performed. What is the result now? R5. So R5 equal to R3 plus R4. So what is R3 and R4 means? R3 we know that R1 plus R2. So finally the value is R5. But how many parallel performances are there? 2 parallelly performed operations are there. So 2 sub operations are performed. What are the 2 sub operations means? One is a multiplier, another one is a adder. So one multiplier and one adder. So 2 sub operations are performed parallelly. So 2 sub operations are performed parallelly. So what are the 2 sub operations means? One is a multiplier, another one is a adder. So multiplier is performed parallelly and adder also performed parallelly. So the resultant value is stored in R5 register. So it is about the parallel operation. So parallel processing is a method to improve computer system performance by executing 2 or more instructions simultaneously. If the instructions of the program are executed in sequential manner, it takes more amount of time to execute all those instructions of the program. So it is parallel processing. So what is a condition means? Suppose I have to perform any of the operation. So all are not performed parallelly. Some of the operations may be performed serially. So but here what is a parallel processing? So what is the advantage of parallel processing means? If you are going for the parallel processing means time consuming and less power we need. So parallelly if you are going, then definitely time consuming will be there and less burden on CPU. But if you are going for the serially means it will be depending on one to another. Suppose A and B and C are performed serially. Why? Because if I am going for the serially, C will be depending on A and B operations. C will be depending on A and B operations. Why? Because I am going for the serial operations. So serially means one will be dependent on another. So if anything will be delay, it will be total should be delay. Suppose I am going for the A plus B into C. Here after the performance of A plus B, then only we have to go for the C. So C is waiting for A plus B operation. Okay. If anything will be wrong, it will be delay. Okay. So when I am going for the serially, the time will be delay. So we are not saving the time. So in the parallel means we are consuming time and less burden on CPU. So parallel processing is a method to improve computer system performance by executing. Computer performance means we are improving the performance of CPU. And when we are going for the serially, the performance of CPU will be very high. And executing two or more instructions simultaneously. Previously we discussed A plus B into C plus D. So how many performance are there? It is one, C plus D another one, and multiplication is another one. So three sub operations are performed, two or more instructions simultaneously. If the instructions of the program are executed in a sequential manner, it takes more amount of time to execute all those instructions of the program. Suppose we have to go for the one program or one operation. So in the sequential manner, we have to perform the program in the instructions. What is the process and how it takes a more amount of time to execute these instructions of the program? We can see one. Suppose I am going for the instruction 1. Instruction 1, fetching, decoding and executing. Instruction 2, fetching, decoding and executing. Instruction 3, fetching, decoding, execution. Instruction 4, fetching, decoding, executing. So every instruction we have to go for the fetching, decoding and executing. Every instruction. So suppose I have the program with 10 instructions. Means every instruction it will go for the fetch, decode, execute. So fetch, decode, execute means it will be lot of time to execute all those things. So that is the reason if we are going for the parallel operation, we have to save the time and we have to consuming of performance on the CPU is very less. So suppose example I am taking, move A comma B, add A comma B, int 03. So it is one instruction, it is another instruction and it is another instruction. So move A comma B, it is one instruction, it is fetching. Where is it fetching means? It is fetching from the memory, fetching and decoding. Decoding means our low level language is converting to the machine level language. Low level is converting to the machine level. High level language is converting to the machine language. So it is a high level language. It is converting to the machine language. Okay. Decoding means converting to the binary. So my move A comma B instruction is converting to the binary, means low level instructions or machine instruction. So this instruction is fetching from the memory and decoding means converting to the binary and it is executing. Okay. If this is true or there is no error in this instruction, definitely it will be execute. If it is anything will be wrong or this instruction is not available in the memory, or suppose in the move I missed some letter, example MO, I missed something. Okay. So is there wrong? Is there? Yes, the instruction will be wrong. How can we execute? Okay, it is fetching and decoding, but not should be executed. Why? Because the instruction, what you mentioned the instruction, that is wrong. What is the correct instruction means? Move. Sometimes if I am using MOVE, it is also wrong. Why? Because our original instruction is MOV only, not MOVE. So it will be wrong. Fetching, decoding will be performed, but it will be not executed. Why? Because the error is there in the instruction. So it is the error. How can we know? Fetching will be complete, decode will be complete, then only it will be telling that the error is there. So shall we wasting the time? Yes, we are wasting the time. Why? Because it will be fetched and it is decoded, binary converted, but it is not executing. Why? Because due to some error. So up to this executing, second instruction is waiting for fetching. Why? Because after the completion of first instruction, we have to go for the add A comma B or into 03 like this. But if I am using parallel processing, every line should be parallel processing. What should happen? Every line it should be separate fetching, decoding and instruction. One should be not depend on another. So it will be fetching and decoding and executing the each instruction. So it is the total operation. Okay, it is one operation and we are dividing as a sub operations. Okay, it is about this one. And if the computer uses sequential approach, the computer performance will be degraded. The enhance the performance of the computer we have to use the parallel processing, and the parallel processing is a method to improve computer system performance by executing two or more instructions simultaneously. By using parallel processing, the performance of the computer will increasing by executing two or more instructions simultaneously according with the serial processing. And a parallel processing system is able to perform concurrent data processing to achieve faster execution of the time. So when I'm going for the parallel processing, the computer uses sequential approach to the computer performance will be degraded. Okay, if I'm going for the sequential, it will be degraded. Why? Because we have to enhance the performance of the computer. Then in the parallel processing, we have to enhance, not sequentially. Okay, and parallel processing is a method to improve computer system performance by executing two or more instructions. Here discussed two or more instructions. I'm using parallelly. If I'm taking three instructions, so okay, three instructions I'm executing at a time, fetching, decoding, executing, performing at a time. Then we have to consume the time and improve the computer system performance. If I'm going for the parallel, if I'm going for the serial, means what will happen? The computer performance will be slow and executing time will be high. So parallel processing is able to perform concurrent data processing to achieve faster execution of the time. So parallel processing system may have two or more ALUs and be able to execute two or more instructions at the same time. Why? Because if I'm using multiple operations, move A comma B and add A comma B. So at a time parallelly I'm fetching, decoding, executing. What will happen? At a time I'm using these operations means I need multiple ALUs. Okay, if I'm using only one ALU, no need of parallel. Serial operations will be performing. So at a time multiple operations, multiple sub operations are going on means definitely I have to use, suppose A plus B into C plus D. So A plus B is performing by one ALU, another C plus D is performing another ALU parallelly. Parallelly I am performing. Okay, so at a time A plus B result will be generated and C plus D result will be generated. Okay, this one taking ALU1 and it is a ALU2. So why I am taking multiple ALUs means at a time the output should be come. Why? Because lesser time consuming and improve the CPU performance, like this. So okay, so it have two or more ALUs to be need. Move AX comma BX, add AX comma BX. So these instructions are executing now. So for this it is one instruction, it is one another instruction. So for this instruction I need one ALU, another instruction I need another ALU. Why? Because at a time two instructions are executing, that means multiple ALUs I need. So one by one is completed, after then another should be start. That means serial processing should be there. So when I'm going for the serial processing, only one ALU need. But when I'm going for the parallel, multiple operations are performed at a time, means multiple ALUs we need to generate the output. And also the system may have two or more processors operating concurrently. Why? Because multiple ALUs already I'm using ALU1 and ALU2. So definitely the system have two or more processors for operating concurrently. So when I'm using multiple ALUs means I need two or more processors I need, definitely. Because one processor, one ALU. Multiple ALUs means multiple processors we need. So multi-processors we need. And what is the improvement when I'm using these multiple ALUs and multiple processors? Means we're increasing the throughput, the amount of processing that can be accomplished during a given interval of time. Okay, in a particular time we are improving the performance. That means we are improving the throughput. When the parallel processing is there, then only we are improving the throughput. That means in input to output, when I'm using parallel performance, then we are reducing the time and we are improving the throughput. And the general basic computer consists of three main components: memory, input output devices, central processing unit. In the CPU, what are there? Means arithmetic logic unit, control unit and registers. So three main categories and three subcategories are there. So when I'm going for the, suppose I'm executing this instruction, what I need? So memory we need to searching this instruction, and input output we need to execute. What is the input? One command I will give, and what is the output for this one. And central processing unit means definitely we need ALU now. So ALU for the CPU we will provide ALU, arithmetic logic unit, and control unit and registers. So these are the three main components we need for the parallel processing in the pipelining. And it is a full functional unit of independent units. Suppose I am taking here the processor with multiple function units I am taking. So processor registers. In the processor registers, what are there? Adder, subtractor, it is one. Integer multiply, logic unit, shift unit, incrementer, floating point multiply, floating point divider. So here I am taking example 8 concurrent registers I am taking. So process register with multiple registers. So what are the multiple operations or multiple register means? Adder, subtractor. Okay, I will go parallelly. Okay, parallelly I will go with integer multiply. So I will not depend on any of one thing. Okay, parallelly I will perform. So these are the possibilities of parallel. What is that means? Adder, subtractor, integer multiply, logic unit, shift unit, incrementer, floating point, add, subtractor, floating point multiply, floating point divider. So these are the functional units of independent units. One will not depend on another. So it is a processing register to memory, memory to process register to memory. Why? Because input to output and output to input, like this. A multiplication or multifunctional organization is usually associated with a complex control unit to coordinate all the activities among the various components. So parallel processing can be classified from the internal organization of the processor, the interconnection structure between the processors, the flow of information through the system, the number of instructions and data items that are manipulated simultaneously. So when I'm going for the parallel processing, the multi-functional organization is usually, multi-organization means multi-processors I'm using, and associated with a complex control unit to coordinate all the activities among the various components. Why? Because I'm using sub operations. When I'm performing sub operations, then I need multiprocessor or multiple ALUs in a parallel processing. So parallel processing can be classified from the internal organization of the processors. So how many processors you are using? Suppose in my system 4 processors are there, means 4 ALUs. So parallelly 4 are possibilities. Suppose I have 2 ALUs, so parallelly 2 are possibilities. And the interconnection structure between the processors. So interconnections of ALU 1, ALU 2, all are interconnected with CPU. Okay, and with multiprocessors. So interconnections we need to perform, and the flow of information through the system. So ALU 1 to ALU 1, what is the output? ALU 2, what is the output? So what is the final output? So that one, and the number of instructions and the data items that are manipulated simultaneously. So ALU 1 is performing one sub operation or sub instruction. ALU 2 another sub operation. So how many sub operations are performing? What is the total operation and what is the total output? That is will be manipulated simultaneously. So these are the parallel processing of the classification. And parallel processing can be divided as 4 categories: single instruction, single data stream; single instruction, multiple data; multiple instruction, single data; multiple instruction, multiple data. Okay, so in the short term we are using single instruction, single data, SISD, single instruction, single data; SIMD, single instruction, multiple data; multiple instruction, single data; multiple instruction, multiple data. So the sequence of instructions read from memory is the instruction stream, and the operations performed by the data in the processor is the data stream. The parallel processing may occur in the instruction stream, the data stream, or both. Suppose I have a instruction with multiple sub instructions. Okay, that is the another thing. But I have one instruction and one data. I have one instruction with multiple data. Multiple data means I'm using only add ax, bx, cx. But these values are using in multiple data, not in the single data. Multiple data are using. So multiple instructions. So multiple. Suppose move a, b, add a, b. Example. So it is only one. That is one addition of 2 numbers. It is belongs to only one operation. Addition of 2 numbers only. But what are that means? Multiple instructions are there, but I need a single data. Why? Because this is completely belongs to only addition of two numbers only. So multiple instructions are there, but only I need a single data. But sometimes what will happen? Multiple instructions are available, multiple data should be needed. So the sequence of instructions read from memory is the instruction stream. So read from memory means read operation is performed, that is the instruction stream, and the operation performed by the data in the processor. Okay, read operation is the instruction set and the data processor is performed, that is a data stream, and the parallel processing may occur instruction and data. So parallelly means I need instruction and data. Parallelly I need both of these. Then only we can execute. And the register R1, R2, R3, R4 hold the data and the combination circuits operate in a particular segment. Any of the parallel processing, I need multiple registers. Why? Because I am performing parallelly. So parallel means multiple registers, R1, R2, R3, R4 like this. When I am going for the serial means 1 or 2 are enough. But parallel means more registers we need to perform. And the output generated by the combination circuit in a given segment is applied as an input register of the next segment. For instance, from the block diagram, we can see that the register R3 is used as the one of the input register combination ladder circuit. In general, the pipeline organization is applicable for two areas of computer design, which includes arithmetic and instruction. So when I'm using multiple registers for the multiple operations, the output generated by the combination circuit. So combination circuit means when multi operations are performed. So that is a combination circuits, and the input register of the next segment. For instance, for block diagram, you can see that register R3. So suppose R1 and R2 performed. So what is the result? R3. So R3 equal to R1 parallelly R2. So R1 and R2 result will be stored in R3. So what are the inputs? R1 and R2. What is the output? R3. But suppose I need R3 into R4. What is the R5? So when I'm R3 is combination with R4 means that is the input. When R1 R2 is performed, R3 is the output. When R3 and R4 is there, then R3 is calling as a input. So it is about the combinational adder. And generally pipeline organization is applicable for two areas. Majorly the pipeline is using for arithmetic and instruction. So when we are using pipeline processing, then parallel processing, then we need arithmetic and instruction. So when I have to perform the operation or perform the program or sub operations or operations, majorly we need arithmetic pipeline and instruction pipeline. So in the parallel processing, it is a pipelining. So it is a pipelining process. It is a pipelining technique to decomposing the sequential process of sub operations. That is called parallel processing. So in a parallel processing, the most important characteristic of parallel technique is several computers can be progress in the distinct segments of the same time. Same time means at a time multiple operations can be performed. That is called parallel processing. Okay, it is about the parallel processing. Suppose R1 and R2 are multiplier with R1. Multiplier means R1 into R2. So what is the result means? R3. So R3 is the output of R1 and R2. Here adder, R3 and R4 are the inputs for the adder. So R3 and R4 are the inputs. And R5 is the result. Result means adder, R3 plus R4. So R5 is the output of adder. That is a R3 and R4. So how many sub operations are performed means multiplier is 1, adder is 2. So 2 sub operations are performed parallelly. It is about the parallel processing. Each instruction we need fetching, decoding and executing. When we are performed parallelly, we no need of fetching, decoding, executing. At a time parallelly, we are performing all those things. Then we are consuming the time. If we are going for the parallel processing, definitely we have to improve the throughput, and we are three main components we need for the parallel: memory, input output, central processing. In the CPU, ALU, control unit and registers we need. So it is a parallel operations with multiple registers of processor. So to memory or from memory is the processor register, and these processor registers are multiple operations. Multiple parallel processings are available: adder, subtractor, integer, multiply, logic unit, shift unit, incremental, floating point, add, subtract, floating point, multiply, floating point, divide. And parallel processing can be classified as 4. The internal organization of the processor is 1. The interconnection structure of the processor is another one, and the flow of information through the system is another one, and the number of instructions of the data items that will be manipulated simultaneously. So these are the 4 classifications of parallel processing. Okay, these are the 4 categories of parallel processing: SISD, single instruction, single data; SIMD, single instruction, multiple data; MISD, multiple instruction, single data; MIMD, multiple instruction, multiple data. So in this, we need instruction stream, data stream. Both I need for parallel processing. So when I'm using multiple operations or using in the parallel organization, definitely we need arithmetic pipeline and instruction pipeline. It is about the parallel processing. In the next session, we'll discuss arithmetic pipeline and instruction pipeline. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.